Welcome to Success Blueprint for JEE and NEET. Join the class 12th chemistry.
Study at your own pace and save your time and energy. Please like and subscribe for more educational videos.
Introduction. Students, today we are going to perform an experiment in our chemistry lab. For this experiment, we require two important components: concentrated sulfuric acid and water. Firstly, we add concentrated sulfuric acid into water very slowly. Both are mixed smoothly. Now we add water into concentrated sulfuric acid slowly. Students, see carefully what happens now. When water is added to acid, spurting takes place and a lot of heat produced during the process. This shows that concentrated sulfuric acid has a great affinity for water. Its dissolution in water is highly exothermic in nature. Therefore, for dilution of the acid, always add acid to water slowly and not water to acid, as sulfur is an important element of P block of periodic table. So, today we'll study about the 16th group of the P block elements. Objectives. At the end of this lesson, you will be able to define group 16 elements, know about physical and chemical properties of group 16 elements, analyze anomalous behavior of oxygen, describe dioxygen, explain properties and uses of dioxygen, define ozone, explain properties and uses of ozone, understand allotropic forms of sulfur, categorize oxoacids of sulfur, explain sulfuric acid. Group 16 elements, the oxygen family. The elements oxygen, sulfur, selenium, tellurium and polonium constitute group 16 of the periodic table. The first three elements of this group, oxygen, sulfur and selenium, are non-metals. The next element, tellurium, is a metalloid. The last element, polonium, is a metal. The general outer electronic configuration of these elements is Ns2np4. They have 6 electrons in their valence shell. General trends in the properties. Atomic radii. The covalent radius of the elements increases down the group. It is due to the increased nuclear charge, which results in greater attraction of the electrons by the nucleus. Ionization enthalpy. The ionization enthalpy values decreases down the group. Electronegativity. Electronegativity of these elements decreases down the group. Elements of group 16 are characterized by high electronegativity. Oxygen is the second most electronegative element after fluorine. Electron gain enthalpy. These elements have relatively high electron gain enthalpy values which decrease down the group. Physical properties of group 16 elements. Catenation. Oxygen to a limited extent and sulfur to a larger extent exhibit the property of catenation. The polysulfanes, polysulfuric acids and various allotropic forms containing different SN rings and chains are known. The sulfur-sulfur bond is very important in biological systems and occurs in proteins and enzymes. Allotropy. All elements of the group 16 show allotropy. Oxygen exists as O2 and O3. Sulfur is found to exist in several allotropic forms such as rhombic, monoclinic, plastic and colloidal sulfur. Selenium has 3 important allotropes, namely rhombic, monoclinic and gray forms. Molecular state. Oxygen molecule is diatomic and under normal conditions exists as a gas, while other elements have larger atomicities and exist as solids. Oxidation state of group 16 elements. Elements of group 16 have Ns2-Np4 outer electronic configuration. They tend to acquire the nearest inert gas configuration by gaining or sharing 2 electrons. Oxygen, the first member of the family, exhibits oxidation state of -2 due to its high electronegativity. Since electronegativity decreases from oxygen to polonium, the tendency for -2 oxidation state diminishes from sulfur downwards. Other elements show additional oxidation states of +2, +4 and +6 due to the presence of d orbitals in them. Chemical properties of group 16 elements. Oxygen is the most reactive of these elements. Some important trends in the chemical reactivity of the compounds of these elements are following. Hydrides. These elements form volatile hydrides such as H2O, H2S, H2SE, H2TE and H2PO. Thermal stability decreases down the group because the size of the atom increases and hence the bond length also increases. Acidic character increases down the group because they can dissociate more easily to give H+ ions. Except H2O, all are reducing agents. The reducing character increases down the group. H2O has the highest boiling point because of hydrogen bonding. After a sudden drop from H2O to H2S, the boiling point gradually increases from H2S to H2TE because of increase of molecular mass and hence van der Waals forces. Halides of group 16 elements. The elements of group 16 form a number of halides. The important halides are hexa, tetra and dihalides. They can be prepared by the direct reaction of the chalcogen with the respective halogen. The compounds of fluorine with oxygen are called fluorides. As chlorine, bromine and iodine are less electronegative than oxygen, therefore compounds of these halogens with oxygen are called oxides. SF6 structure involves sp3d2 hybridization and is octahedral. SF4 structure involves sp3 hybridization and is trigonal bipyramidal with one position occupied by a lone pair of electrons. Assessment. Before proceeding further, let us know how much you have learnt. Drag and drop the correct option. Oxides of group 16 elements. All elements form a variety of oxides. All elements form dioxides with a general formula MO2. The acidic character of these dioxides decreases down the group. SO2 is acidic, SeO2 is weakly acidic, while TeO2 is amphoteric. All elements form trioxides. The molecule of SO3 is resonance hybrid of 3 structures and has trigonal planar structure in gaseous state. Anomalous behavior of oxygen. Oxygen differs from rest of the elements in the family in the following respects. It shows oxidation state of -2 in its compound, while other elements show additional oxidation state of +2, +4 and +6. It exists as diatomic molecule, but other members exist as polyatomic molecules. It is capable of forming pi-pi bonds with elements, but other elements do not show such tendency of forming multiple bonds. Dioxygen is paramagnetic, whereas other elements are dimagnetic. It is gas at ordinary temperature, whereas the other members are solid. Dioxygen. Oxygen is the most abundant element found in nature, both in free and combined state. Nearly all rocks, clays, and many minerals contain a high proportion of oxygen. Preparation of dioxygen can be done by following methods. By the action of heat on certain metal oxides. By the action of heat on certain alkali salts which contain oxygen. By decomposition of H2O2. On commercial scale, dioxygen is manufactured by electrolysis of water. By fractional distillation of liquid air. When liquid air is distilled, nitrogen with lower boiling point distills out first, leaving behind practically pure dioxygen. Properties of dioxygen. It is a colorless, odorless and tasteless gas. It is slightly soluble in water, which gives vital support to marine and aquatic life. It is very reactive. The reaction rate increases with temperature and in presence of the catalyst. All metals in electrochemical series combine directly with oxygen to give oxides. Sulfur, phosphorus and carbon burn rapidly in dioxygen, forming their oxides. Many compounds also react with oxygen. Uses of dioxygen. It is used in breathing apparatus. Oxygen cylinders are widely used in hospitals, high-altitude flying and in mountaineering. It is used in burning of fuels. It is used in production of steel. It is used as an oxidizing agent. It is used in welding torches. Simple oxides. A binary compound of oxygen with another element is called oxide. Oxygen combines with most of the elements to form oxides. An element having variable valency forms many oxides. For example, PbO, PbO2 and Pb3O4. On the basis of their nature, oxides can be classified as follows. Basic oxides. An oxide which dissolves in water to give an alkaline solution or reacts with an acid to form salt is called a basic oxide. For example, Na2O, K2O, MgO and CaO. Acidic oxides. These oxides, when dissolved in water, give acidic solution, or if not soluble in water, then react with a base to form salt and water. For example, SO2, N2O3, P2O3 and Br2O. The acidity of the oxide increases as the oxidation number increases. Amphoteric oxides. Some oxides show characteristics of both acidic as well as basic oxides. For example, ZNO, Al2O3, GeO and PbO2. Neutral oxides. Those oxides which are neither acidic nor basic are called neutral oxides. For example, CO, NO, N2O and H2O. Ozone. Ozone is allotropic form of oxygen. Under certain conditions, 3 atoms of oxygen combine together to form triatomic molecule of ozone. When a dry, slow stream of oxygen is passed through a silent electric discharge, there is partial conversion of oxygen into ozone. Since the formation of ozone from oxygen is an endothermic process, it is necessary to use silent electric discharge. The apparatus used to obtain ozone is called ozonizer. Siemens ozonizer. It consists of 2 coaxial glass tubes sealed at one end. The inner surface of the inner tube and outer surface of the outer tube are coated with tin foil. It gives 10 to 15% ozone-oxygen mixture. Properties of ozone. Pure ozone is a pale blue gas with a characteristic pungent smell. It is slightly soluble in water. Ozone is thermodynamically unstable with respect to oxygen, since its decomposition into oxygen results in liberation of heat and an increase in entropy. Due to ease with which ozone can liberate an atom of oxygen, it acts as a powerful oxidizing agent. Under the action of ozone, a shining silver surface blackens rapidly, being covered by a layer of silver peroxide, Ag2O2. When ozone is passed through mercury, it loses its meniscus and sticks to the glass due to formation of Hg2O, which dissolves in mercury. This phenomenon is called tailing of mercury. Uses of ozone. The important uses of ozone are following. It is used as deodorant to destroy odor in kitchen and restaurants. It is used for bleaching oils, flour, starch and ivory. It is used as germicide and disinfectant for sterilizing water. It is used in the manufacture of artificial silk and camphor. Allotropic forms of sulfur. Rhombic sulfur. This is the most stable form of sulfur. It is obtained by slowly evaporating a solution of rolled sulfur in CS2 when octahedral crystals of rhombic sulfur are formed. This is lemon yellow in color. Monoclinic sulfur. If crystals of rhombic sulfur are slowly heated to 369 Kelvin, they slowly change into needle-like variety called monoclinic sulfur. This form is stable above 369 Kelvin. It has dull yellow color. It is insoluble in water. At 369 Kelvin, both rhombic sulfur and monoclinic sulfur coexist, and this temperature is called transition temperature. Sulfur dioxide. Sulfur dioxide can be prepared by burning sulfur. In laboratory, it is prepared by the reduction of H2SO4. Metals react with hot and concentrated H2SO4 to form SO2. On commercial scale, sulfur dioxide is obtained by roasting sulfides. Roasting means heating a metallic sulfide in presence of air or oxygen and converting sulfide into an oxide. Properties of sulfur dioxide. It is a colorless gas at ordinary temperature and has disagreeable and suffocating smell. It reacts with alkalis, forming sulfides and bisulfides. In the presence of moisture, it acts as a bleaching agent. It is quite soluble in water and solution is acidic. It acts as a strong reducing agent in aqueous solution. It acts as a good oxidizing agent. For example, at 1000 degrees Celsius, it oxidizes carbon into CO2. Uses of sulfur dioxide. The important uses of sulfur dioxide are following. In the manufacture of H2SO4, H2S and calcium hydrogen sulfide, which is used in paper and pulp industry. It is used as an anti-claw and disinfectant. It is used as a preservative for canned food. It is used in refining petroleum and sugar. It is used as refrigerant. It is used in bleaching. Oxoacids of sulfur. The sulfur oxoacids are chemical compounds that contain sulfur, oxygen and hydrogen. Sulfur forms a number of oxoacids. Some important oxoacids of sulfur are the following: H2SO3, sulfurous acid; H2S2O4, diathenious acid; H2SO4, sulfuric acid; H2S2O3, thiosulfuric acid; H2SO5, permonosulfuric acid; H2S2O8, per-disulfuric acid. Some of these acids are unstable and are known in aqueous solution or in the form of their salts. Sulfuric acid. It is the most important oxyacid of sulfur. It occurs in certain minerals and springs. It has large application in industries and is also known as the king of chemicals. Sulfuric acid is manufactured by contact process. The process involves the following steps: production of sulfur dioxide. It is carried out by burning powdered sulfur or roasting of sulfur-rich ores. Oxidation of sulfur dioxide. This step is the key step in the manufacture of sulfuric acid. To yield better sulfur trioxide, the favorable conditions are the following: temperature. As the reaction is exothermic, a low temperature favors the forward reaction. An optimum temperature is maintained between 673 to 723 Kelvin. Pressure. A high pressure favors the process. An optimum pressure of 1.5 to 2 atom is maintained. Catalyst. At such a low temperature, the reaction is slow. The catalyst employed is divanadium pentoxide, V2O5. Excess of oxygen. To have a better yield of SO3, O2 is used in excess. Conversion of SO3 into H2SO4. SO3 is absorbed in concentrated H2SO4 to get oleum. Oleum then is diluted with water to get H2SO4 of required concentration. Manufacturing of sulfuric acid. The manufacturing of sulfuric acid starts from sulfur burner. Here, sulfur dioxide is produced. This sulfur dioxide passes through dust precipitator, which removes dust from the gases. A scrubber is used to remove the soluble impurities. After that, drying tower removes the moisture from the gases. Then, gases pass through an arsenic purifier, which removes impurities of As2O3. The gases coming out of the purification unit are passed through the testing box to make sure that they are completely free from the impurities. The pure gases coming from the testing box are preheated to 673 to 723 Kelvin in a preheater. The hot gases are then passed through the catalyst chamber, where SO2 is oxidized to SO3. SO3 is introduced at the base of the absorption tower, from the top of which concentrated H2SO4 is showered. As SO3 gas moves up, it is dissolved in sulfuric acid, forming oleum, which may be drawn out from the base of the tower. Oleum is then diluted with water to get H2SO4 of the desired concentration. Properties of sulfuric acid. In pure form, it is colorless, but commercial acid is yellow in color due to the presence of impurities. On coming in contact with the skin, it produces severe burns. Concentrated H2SO4 has a great affinity for water. Its dissolution in water is highly exothermic in nature. Highly concentrated H2SO4 has high boiling point of 621 Kelvin. It shows that H2SO4 has associated structure due to hydrogen bonding. On heating strongly, it dissociates into SO3 and H2O. Uses of sulfuric acid. The important uses of sulfuric acid are following: It is used in metallurgy for electrolytic refining of metals. It is used as a dehydrating agent. It is used in storage batteries and lead accumulators. It is used in fertilizers for the preparation of ammonium phosphate, ammonium sulfate, and superphosphate of lime. It is used for cleaning of metal surfaces before electroplating. It is used as an acid in laboratories and industries. Assessment. Before proceeding further, let us know how much you have learnt. Drag and drop the correct option. Did you know? Sulfur is used as fungicide to protect grapes and strawberries. Oxygen was discovered by Carl Wilhelm Scheele in Sweden in 1771. It was named by Antony Laurent Lavoisier in 1774. Selenium is widely used in rectifiers and in xerography. Summary. Let us summarize what we have learnt. The elements oxygen, sulfur, selenium, tellurium, and polonium constitute group 16 of the periodic table. Elements of 16th group have relatively high electron gain enthalpy values which decrease down the group. Oxygen molecule is diatomic and under normal conditions exists as a gas, while other elements have larger atomicities and exist as solids. Oxygen shows oxidation state of -2 in its compound, while other elements show additional oxidation state of +2, +4, and +6. A binary compound of oxygen with another element is called oxide. Oxygen combines with most of the elements to form oxides. Ozone is allotropic form of oxygen. Under certain conditions, 3 atoms of oxygen combine together to form triatomic molecule of ozone. The sulfur oxoacids are chemical compounds that contain sulfur, oxygen, and hydrogen. Sulfur forms a number of oxoacids. Concentrated sulfuric acid has a great affinity for water. Its dissolution in water is highly exothermic in nature.
Friends, welcome to Kwiiz Success. Are you tired of memorizing without really understanding concepts for exams? Our innovative learning techniques help students grasp concepts easily and effectively. Our Success Blueprint course for class 11 and 12 gives you a real exam-like experience, helping you build confidence and score higher in IIT-JEE and NEET. Here, you'll find the perfect combination of 3D animated videos, AI-powered test series, and ebooks enriched with MCQs and mind maps. All our courses are designed by IIT and IIM alumni to ensure top-quality learning. For online courses and ebooks, visit www.success.org.in. Download the Success Kwiiz mobile app for free. For advanced test series and free mock exams, visit www.kwiiz.success.org.in. Download the Kwiiz Success mobile app and get a real improvement in your scores. Success is now in your hands. Thousands of students have already benefited from Kwiiz Success. Now it's your turn. Study from home, learn at your own pace, and prepare at your convenience. Don't forget to subscribe to our YouTube channel, Kwiiz Success, and share it with your friends. Thank you, and all the best for your success.